I think a lot of it's,
Sorry.
I guess it says it's being recorded. Um, it's kind of an innocent little adapter that seems like it has a lot of use for us because it combines WR28 and WR42. So if you go on to the next slide, Jim, of course, WR28 on the right, that's normally 26 to 40 gigahertz and a low frequency cutoff of 21.1. And on the left, WR42, 18 to 26. So this certainly looks like it would be a perfect adapter for going between WR42 and 28. And it's interesting, it has a piece of double ridged waveguide down the WR28 side of things. And, when you go online to try to look at the cutoff frequency of WR28 rigid or any rigid waveguide for that matter, you don't find you don't find a lot of information on it. But I've always seen it touted as being a greater bandwidth than standard non-ridged waveguide. So why not use this little guy at 24 gigahertz? Go on, Jim. Well, this is why you don't use it because it really doesn't work. This is a plot from, I got to squint at, I think this was 20 to 40 gigahertz, S21 or loss. And it's 10 dB per division. And that doesn't look like it works well anywhere. And for sure, 5 dB a loss at 24 gigahertz. And a good friend of ours on frequency here, Tony, was initially using this adapter, actually a couple of them in his rig. And then we figured out that this little critter has this much loss, so they're no longer in the system. But I remember Barry B4MA telling me a long time ago that you had to do some work on this thing to make it work. And I thought, well, let's just figure out what it's capable of as is and what happens when you modify it. Go on to the next one, Jim. So initially, I wanted to figure out, well, what is this thing used for? Well, if you go back to a 1971 application note, which was, gosh, I think I was still in college at the time. It actually attaches to this mixer that you see in this photo, and it's used for extending the high frequency range of a spectrum analyzer. And typically, you've got an RF connection on the side there. That's WR28 rigid, and then you've got a BNC connector on top, which is good for subharmonically pumping the mixer. And then you've got three pieces of waveguide. The one on the bottom is straight WR28 um, going up to 40 gigahertz. The one in the middle is the one we're talking about now, WR42 on the left side, 28 on the right. And then the third one is WR62, which is 12.4 to 18 gigahertz. And theoretically, this thing will convert signals that are in the 12 gigahertz to 40 gigahertz range all into that one little WR28 spigot. And I haven't quite figured out how that happens because theoretically it cuts off at 21 gigahertz, or WR28 does so. But still, when you Google it, you find that EM modeling is required. So it's kind of like, well, okay, I guess it must have worked, but it doesn't work where we need it to work right now. Anybody have any thoughts on the dual ridged waveguide? I think Kent's on frequency there. It'd be interesting to figure out how they get 12 gigahertz into that mixer, but yet the waveguide's not very long, so something must trickle in. Because if you look at the sensitivity of this guy in that app note that I referenced there, it's got decent sensitivity, down to 12 gigahertz. Any comments from anybody out there on how this thing has worked in the past, umpty years ago? Nah, I'm not hearing anything. Go on, go on there, Jim. Now, I wanted to throw this out here. I always go back to this because Pasternak's got a real nice waveguide uh, calculator. And you put in the WR whatever, and it'll tell you the actual low frequency cutoff on it. And that's where I came up with the 21.6 gigahertz cutoff for normal non-ridged WR28. So just something to consider if you want to play around with waveguide calculations. Pretty basic, but it's still a basic waveguide calculator. Go on, Jim. So what I told Tony he needed to do was to go file out the ridge. And that's exactly what he did, using a little jeweler's type screwdriver or hobby file, I guess. And you can see on the right, there's no longer a ridge, but it was well worth it, as you can see on the next slide, because I measured the loss again. And it's almost immeasurable. Of course, it's the same 10 dB per division, but you can see it's like less than a tenth of a dB of loss at 24. So if you really want to use this little guy, and it's not real small, it's like almost, I think it's 3 inches long, but it will work if you get rid of the ridge. But on the other hand, what works better than this is a two-piece arrangement that W1 gigahertz Paul Wade has for converting to WR28 to 42. And I think it's a single piece. It's more like the geometric mean between 28 and 42, which is WR34. And that works really well. So if you don't have a lot of space, check out Paul Wade's website and see if he still lists it up there. But he's made quite a few of these, and they work very well and take up considerably less space. But anyway, I'm not going to spend any more time on it, but it's interesting that it must have worked down to 12 gigahertz at one time, but not for our applications.
Al, if you had a ridged transition at the other end, I bet it would have been flat across the whole area.
Well, yeah, and I thought about that, and I took a WR62 normal transition to coax and a WR28 transition to coax, and I couldn't get it to work good anywhere.
You're
So
not 200 ohms impedance.
yeah. Well, if you have any, it would be interesting. If you had one for WR28, I'd put it on the analyzer.
I've got quite a few for lower frequencies, but the ridge, if you take like a 10 gig waveguide and put a ridge in it, then it becomes 2 to 10. So the ridge greatly lowers the frequency response to the waveguide.
Does it cut away at the high end?
The high end stays basically the same.
Okay, well, that's interesting. I was hoping that you would chime in on that. I've got some double ridged or single ridge WR90 also.
And you'll find that it goes much lower than 8 gig, excuse me.
Okay. Well, it'd be interesting to get a transition and try that out. I would like to see the results of that just to learn something new.
They're very popular in the electronic warfare field because of the very broad frequency response.
Got it. Makes sense. Tony, do you have any comments on your masterful work here? I think Tony was in here somewhere.
Yes, I hope he was still here because I was going to ask him if this new line of business that he's going into.
It takes way too long. Way too long.
He needs a die filer. That's a file that fits in a die filer. Back when they were making dies, stamping dies for sheet metal, they file the die out with a little vertically oriented file that oscillated up and down. Looks like a miniature jigsaw, except it takes files.
I figured there was a better way to do it. Any other comments or questions from the group?
Now, is the real story here is that it's much less expensive to go about it this way than it is to buy one that's got this spec to it.
Yeah, just get yourself a garbage can and a file and sit down in front of NCIS reruns. All right, that's all I got on this one, Jim. Thank you.
Hey, thank you, Al. Any other questions for Al before we switch?
A question actually for Al. Could you kind of link any documentation in the chat of kind of you discovering this and kind of documentation for this mixer, kind of this application? And if anybody has documentation on the rigid waveguide, because I believe it is a connection between like, coax and a waveguide, could you also link that in the chat? I'm interested in getting more experience with waveguides looking forward.
Okay, who are we speaking to?
This is Roman Venegas. I am going to be the presenting, or one of the presenters for the IEEE MTTS TAMU chapter. I am KJ5KFN as well.
If you
Okay.
look up standard waveguide frequencies, a large number of those charts include the ridged waveguide and their frequency responses.
Perfect. Can you type that in chat of what I should Google up?
Ridged waveguide.
Oh, just which ridge waveguide? Got it.
Well, I couldn't find anything, Kent, so I guess if you find something, let us know.
Roman
Roger.
and everybody, we will have the presentations on our website.
Got it.
There, somebody has put something in the chat. I warn you, it's a bottomless pit, just like most of this stuff.
Right.
I think you know that already.
Yep. I already know what to sign up to, but thank you.
Okay, all questions are allowed. So I'm going to talk to you about the latest wave of WaveLab implementations. And we'll start off with some items that are in common for what you're going to see here. The PA0 MHE WaveLab control board, which we've been getting manufactured in China by JLC PCB for 2 years. I think it's even more than that now. We've had 10 orders. We shipped about 210 of these boards. And the number 11 build is in progress. I did run into a problem with the 3.3 volt regulator coming up short at the factory there. So I had to pre-order it, and they gave me a 3-week lead time to get that part in stock. So also noticing mild or modest price increase on some of the parts. Some of them haven't changed. The 4351 synthesizers still around $10, but there are some part price increases. Then all of these units will have an XP style WaveLab module as opposed to the XIN. And what's really different here is that they're all using a radio waves HP CPE 12-inch dish. Then for switching purposes, some of them have a latching SMA relay, some of them have a standard 12-volt relay. And then there will be the necessary WR42 to SMA transition, and that's centered over the circular waveguide opening. You'll see all this shortly. then everyone's using a real standard DC to DC converter. And we're learning that we should be above 7 volts to get regulation, and 7.5 is where we're kind of settling in on. And then there are implementations of the 10 megahertz TCXO, but MATS is using a GPSDO. Here's the radio waves dish. And you can see on the left side, from the back of the dish, you can see the circular waveguide opening. It seems like it's somewhere around 3/8 inches. And then on the right, you can see this dish hanging on a pot, and it's got a monster mounting bracket system. The dish has pretty good gain, not too hard to point. So the one we're using is on this first line, 1 foot mid band, which, they're speccing it down here around 21.2 to 23.6, but it's working very well at 24.192. So it's probably 30 dB or better dBi. Beam width around 3 degrees, so not too hard to point. So we'll start off here with Kevin Hobbs' setup. It's very basic. You can see the control board is this green printed circuit board over here, the one that we're having made in China. And he's got heat sinks on these 2 regulators. They tend to be a little warm. And then he's got a DC to DC converter here. Everyone's using, well, all the pictures are going to show this one. Pretty ubiquitous. Then the WR42 transition here over the center of the waveguide, and he's using a 12 volt SMA relay. Now here is Keith's rig. WB5ZDP. I got to give the cat something to play with. Now, in Keith's case, there's some extra stuff here, and he may take some of this apart and not want it, but I put it on here. And so that at the top, that's a demi sequencer. Just below it is a latching relay driver board. And then the waveguide transition is next. And then the SMA relay is just barely visible. Got the yellow and blue wire running to it. Below that is the DC to DC converter. And then the control board and the WaveLab module over here to the left. To the right is the 10 meg reference. And Bob Strickland 3D printed some nice little cases. And this is the first time I've got to use one. So I stuffed his reference into this plastic box. There's a big switch here, PTT switch, put it into transmit mode. And he's chosen the 432 IF. And here is Matt's implementation that he built. On the right side, this is the picture of the rig in transmit. So you see this bar graph up here. It's just a relative power output. It's got a pot on it. You can adjust it if you want it to be top of the green or one red bar, whatever. Now, it's a little hard to see, but there's a black wire that comes off of that bar graph LED printed circuit board, and it's attached to the rightmost pins of this header pin set, and that is the little monitor that's in the module, and it looks like I'm not going to say it's a directional coupler, but if you look at the actual printed circuit board inside the module, don't open your module. But if you were to look at it inside there, it's got on the transmit out of the PA trace, it's got a little parallel trace with a diode on it. So that's what's coming out of here. And there's some voltage present. We did find that monitoring this line for maximum deviation, if you want to call it that, maximum voltage, is not the compression point P. That you're better off using current to do that. Of course, you've got to have a power meter hooked up and then play with all these factors so that that's how you learn it. On the left side is the receive position. So over here on the far left, you'll see 3 LEDs. There's 4 actually, but that second one down is not lit. But on the right picture, you see the second one down is lit. The third one is extinguished. And that's the difference between transmit and receive on the board. Matt has put his controls and jacks and whatnot on the front here, which is nice from, nothing going to get pulled off, especially if the dish gets tossed off the tripod. He's got heat sinking on the top of these regulators. I looked at them pretty close, and he's also got a big strip of heat sink stuck on the back because the module doesn't extend all the way to the end of the board. So this last quarter, 25% of the board, is not sitting on the module. It's just hanging out in the air. So he put this long heat sink on the back and then these 2 on the front. He said he got those from Amazon, and they just got like some conductive thermal tape. I thought that was pretty good. And Matt's found that he could center the WR42 transition over the circular waveguide simply by using a hose clamp. Just so happens that the square flange size, the corners come right out to the edge of the circular casting. So it's a perfect match to use a hose clamp like this, and it will get you on center. Well, Matt uses a GPS DO, and he's given me these pictures so that you can see. This is a 50 amp power supply, and he's got rovers for everything, all the way from, I believe, from 6 meters all the way to 24 gigahertz now. And so one GPS, he will have to power down one transverter, power up another. Well, maybe he keeps most of them powered and just switches the GPS DO. And there's nothing like success. So about a week ago, before Keith had this in his hands, I went over to Midlothian. It's about 30-minute drive for me, and fired this up, and Al and I had 599 CW contact at 81 kilometers. You can see this Midlothian location on the left side of the profile has a few kilometers of drop before there's any ridges. And I think that's all it takes to get the frontal zone developed and launched. And obviously at 81 kilometers, we're meeting in the air somewhere in the common volume. Now, I didn't give Al the right treatment over here because when you use this, hey, what's that profiler, you're supposed to add in your partner's tower height. So if I had done that, this red line would be almost above this ridge. I think it might even be above this ridge. But I didn't discover it in time to fix it. Barely visible here. I did learn that this GPS, I'm sorry, the TCXO is off enough that after multiplication, Al's signal, which was at 24.192.100, is displaying on this IF radio at 123.123. So I'm not sure how Keith will finally implement all of this, but it's just if you know where your partner is, then away you go. And this ICOM 705 is pretty nice with the waterfall, but I'd already knew that it was going to be high from testing it on the bench. Keith, do you have anything that you'd like to add to this? Here? Maybe he's dedicated to the contest.
Who was the question to?
Keith, WB5 ZDP. Yeah, no, I don't see him here. Okay. Any other questions on what you've seen here?
Yeah, just you go.
Sorry,
Go ahead, James.
Oh, okay, thanks. I was just curious, is this a record for the band in terms of distance?
No.
Okay. All right. I'm still very new to the whole microwave thing, so I know
Yeah.
distance records are very much a thing, so I'm kind of interested in hearing, where the kind of, current distance records are.
Thousands of miles.
They are compiled. You probably type in ARRL records.
Okay.
And it's a big multi-page web page because the records are kept by frequency and by propagation mode.
Okay.
So for a meteor scatter contact, that's a category by itself versus tropospheric ducting, which we're going to get to hear about today.
Yeah, interesting. I see a record here for the, 2.3 gig, and I see a very familiar call sign here for a tropo record. So that's pretty cool. I might try to rally the troops at MTTS one of these days, go maybe have a crack at one of these records one of these days.
Very good. For some folks, that's the driving force, or it is always in the back of your mind that today might be the day.
Right.
Yeah,
And
the record is 543 kilometers.
What is it, Al?
543 between me and WW2R in Mississippi.
Say that one more time, please.
Yeah, I'm groggy. The record's 543 kilometers between myself and Dave Robinson when he went over to, I think it was Jackson, Mississippi.
You were at your place in Allen?
Yeah. Mm-hmm.
Mm, Had a lot of ground to cover.
It's been a tough one to make longer.
When was that set?
Oh, September 7th, '02.
I'll bet there were some other good contacts that day.
I don't know. That was kind of a strange day. That's where Dave Robinson said, "I'm going out," and no cell phone contact. He went up on a building. We worked on 10 gigahertz, QSY to 24, and I couldn't believe it when I heard him and worked him. But
We could,
around here, Jim and I do, I think, what, a couple hundred or 180 kilometers, something like that. Say 200 to be 120 miles.
yeah, I think we got 195 in the log a couple times.
And a whole 99 on 47 gigahertz.
Oh, that was one of those. Oh, can't believe that. Yeah, quite a shock that day. I just drove up that hill with Matt riding shotgun, and I said, "This is not going to be a good day for microwave because it's 70% humidity out there." But this worked. I think we could have one whole NTMS meeting just talking about war stories.
Yeah.
A favorite expression
And
of mine has. Oh, sorry. Go ahead.
oh, I was going to say, and that would make that meeting different in what way?
I was gonna add, don't threaten people with a good time, you know.
Yeah,
And don't talk about dollars per QSO.
yeah, that either. Yeah, we should do that one day. And we should just have like a couple of categories like what was your first contact ever? No matter what the band is. What's your longest? What's your most expensive? Of course, bouncing off the moon is not a small thing.
Especially back in the 1980s.
Right. No internet, no digital.
I had
No
one
one,
question.
no one to build upon either.
Let's move on. Um, so we're ready to, I think, turn control over to Roman. Are you ready, Roman?
Yes, sir. Am I able to share my screen?
Yes. I think I may have to stop. I'm not sure how to stop.
Let me see. I think I could replace current share with my own. So I think I'm gonna do that.
Yep.
If y'all could see it,
Yes, sir.
perfect. Well, James is gonna take it away.
All right, cool. Howdy, y'all. We're MTTS TAMU, the IEEE Microwave Theory and Technology Society at Texas A&M. I'm James, KI5UXW, and I'm here with my chair, Roman Venegas, KJ5KFN, and a member of our Interorganizational Coordination Committee. I think I got that right.
Yeah.
Eric Song. Next slide, please. Here's the agenda we'll be talking about today. I'm going to ask that if y'all have any questions, save them to the end so we can kind of get through the whole presentation, have as much time afterwards for questions. Next slide, please.
This kind of goes into my introduction. So howdy, my name is Ron Venegas, just like James said. I just graduated from Texas A&M for the class year 2025, and I'm now pursuing a master's degree at Texas A&M. My accomplishments within the RF microwave community is being a two-time IEEE author as an undergraduate, as well as participating in the International Microwave Symposium in 2024, provided by IEEE's Project Connect. It's where I got out to go to DC and participate in the largest congregation of microwave and RF engineers and companies, and kind of where I got my idea for starting this chapter to kind of help people like myself during that time to get more involved in the RF and microwave community. And my current projects right now is now to graduate grad school. My thesis is going to be based off of emulation of a memory-based processing for radar. We're using something like a memristor crossbar array, and then building a SDR kit with flexible antennas for a new initiative at Texas A&M called the Junior Research Scholars that helps students get into the research and kind of the graduate program at Texas A&M.
All right, so howdy, I am Eric Song. I am electrical engineering class of 2027. As a member of MTTS, the interorganizational committee, I joined to be with other RF-minded individuals interested in spreading the enthusiasm for RF and microwave technology. I'm currently conducting research under the director of one of the labs here, the IMSL, or the Intelligent Electromagnetic Sensor Laboratory, on more cost-effective ways of waveguide calibration. So like aiming to match the accuracy of expensive calibration kits while reducing expenses. My immediate goals are to graduate, to continue researching RF and microwave engineering, and also learn about PCB creation, and also increase my proficiency in MATLAB, which has proven very invaluable to the IMSL research that I have. All right, next slide.
Well, howdy y'all. As said earlier, I'm James Irvin. I'm a general engineering student at Texas A&M. I am in the ETAM process for electrical. I'll hear back in mid-July, so fingers crossed. I'm a extra class amateur radio operator with the call sign Kilo India 5 Uniform X-Ray Whiskey. I was licensed all the way back in 2022 as a part of the Lhasa High School Amateur Radio Club. I've done a little bit of ham radio research. During the solar eclipse in 2024, the ham sci cohort were running some research experiments to collect data on, how the eclipse affects propagation on HF. And so one of the things they need to do was deploy a whole bunch of receivers. So they reached out to me and the LASA Club, and we set up a whole bunch of receivers around Austin, record a whole bunch of really cool data. I can talk about that more later. I am a member of the Event Coordination and Technical Education Committee at MTTS TAMU. So my committee is the one who is in charge of planning, organizing all the events, workshops, you name it. I joined MTTS TAMU to learn more about RF and microwave engineering and, potentially a stepping stone into a professional career, and also to meet other students who are passionate about it. Yeah, so to describe some of the photos here, up there at the top left, that's myself and another graduated Aggie ham, Hudson Spillers KL4LJ. The two of us, along with another ham, we hiked up to the top of one of the peaks in Bandera, Texas, for summits on the air and parks on the air. It was loads of fun. Hill Country State National Area, tons of contacts, the most quiet RF conditions I ever had, and it was loads and loads and loads of fun. Right there on the bottom left, that's me working winter field day from the E-Quad at Texas A&M. I'm pulling what looks to be some pretty multi-handed double duty. I was logging on my laptop. I think I was messaging someone on Discord, and then also working someone on 40 meters. So pretty busy, but loads of fun. And then there on the right is my brother and I in the backyard, building an HF vertical and having a bit of fun with that. My current projects and goals are to graduate. Easier said than done sometimes. I'm also learning C++ right now. And I'm also trying to get on the VHF and UHF microwave bands. I was going to be on the contest this weekend, but the 706 that I have, the old digital interface did not work, so we'll give it a go next time. I'm also redoing my HF Go kit for the nth time, and also trying to learn more about RF engineering whenever I can. Next slide, please. So we can summarize MTTS TAMU with its mission and vision. The mission is to facilitate an environment that helps students expand their knowledge of microwave and RF theory, learn applicable skills related to microwave and RF engineering, and grow as student leaders. And our vision is to have all members become engineers who gain confidence in the practical knowledge of RF and microwave engineering as they prepare to pursue jobs in the microwave and RF industry. Officially, MTTS TAMU will start in the upcoming fall semester, so fall 2025. So right now we're spending all the summer planning, organizing, making sure that, we're ready to go whenever the semester rolls around. Next slide, please. So, RF and A&M go way, way, way back. It starts, back in the early 1900s when the Corps of Cadets established a signal corps. So here we have some archival photos of, cadets doing radio. Up there on the top left, we have a bunch of cadets setting up an inverted V antenna, obviously for NVIS communications. Up there on the top right, we have them laying out what looks to be some sort of transmission line. And then the bottom right, probably maintenance and operating some equipment. And then on the left, a pretty fun photo is, all these cadets sitting at tables, uh, learning how to do Morse code, so actually taking time out of their day and in classes to learn how to do Morse code. And so MTTS TAMU is committed to help bring this RF community with its rich history into the modern era. And how are we going to do this? We're going to do this with, workshops and teaching our students how to use, cutting edge and, industry standard software and equipment, software like Cadence AWR, ANSYS, HFSS, and also holding a bunch of workshops where students get to put all these skills that they learn in practice to, get hands-on and build stuff. Next slide, please.
All right, so MTTS has these kind of activities. So we'll have bi-monthly general meetings, graduate student presentation sessions, microwave and RF industry speaker sessions, coding, simulation, hardware workshops hosted by us, hosting semester-long workshops leading up to student competitions like Battle of the Dishes, volunteering and traveling to international microwave symposiums, and participation in big events and other community outreach programs. Next slide. So here are the current events that are being developed. So the first one is the Rhodey and Schwartz Get to Know the Company event. This is where we do some sort of equipment demo with Rhodey and Schwartz and also discuss employment opportunities. We have the MathWorks sponsored student competition, the Battle of the Dishes. This is an event where you use some basic materials such as wood and aluminum to create a parabolic dish with low-cost materials, and also an SDR, which is a software-defined radio. That's the dishes that you see on the right. And also the next event is the Cadence Microwave Design Workshop, which is where we design some microwave devices with Cadence's AWR software. IMS cell vector network analyzer training. So I've already been through this because I'm researching for this lab, but it's basically a VNA training session hosted by the director of the lab, and also delving into the use of the VNA on some circuits such as a low noise amplifier or no low noise amplifier and low pass filter, and also any type of antenna, and also learn about the extensive calibration techniques needed to set up proper measurement. And you can see the IMSL logo down there. Also the MTTS TAMU and W5AC Foxhunt. ANSYS HFSS workshop, which helps expose people to an electromagnetic software built for RF and microwave testing, and also guest speakers and IEEE distinguished microwave lecturers. All right, next slide. So how can NTMS help us accomplish our mission? So NTMS can be Elmers to MTTS members. We can have presentations and speakers on microwave topics, participation and support from MTTS TAMU microwave operating events, such as the Fox Hunt on the past slide, and also participation in microwave ham radio events. Equipment gear support, such as how NTMS has given an RF0 beacon, a noise figure meter, a noise source, and frequency meter, which all help to fulfill our mission. Planning support for MTTS TAMU workshops, hosting and supporting workshops on low noise amplifiers and RF0 beacons, introducing MTTS TAMU members to microwave activities, and also allowing MTTS TAMU members to network with NTMS members. Next slide.
So, what will NTMS gain from being a sponsor of MTTS TAMU? Well, for starters, we're going to try our hardest to get regular attendance by MTTS TAMU and its members to NTMS monthly meetings. There, we'll give presentations and status reports on MTTS TAMU events and achievements. We're also more than happy to help y'all with any antennas and RF circuits y'all might have, as we'll be learning how to use Cadence AWR and ANSYS HFSS. So, we're more than happy if you guys have a project for, say, an amplifier, oscillator, antenna. We'd be happy to help you out with doing some of the modeling with this, cutting edge software. We'd also participate in any microwave operating events that y'all have during the school year. Also, help you all out just in general with any projects and efforts that, have y'all have going on. Also, you the individual for, helping and mentoring MTTS TAMU members, you're helping to train the next generation of microwave engineers and hams. So your efforts will not go unnoticed or unappreciated. Next slide, please. So, thank you all so much for your time and, thank you all for being one of our sponsors. And, one big Aggie Land thank you to all of our sponsors, which we have here at the bottom of the slide. We will now take any and all questions, comments, concerns, remarks, jokes, comments about the weather, you name it.
I have one comment when you get ready to fill out your resume and apply for a job. Do not, under any circumstances, never put your preferred pronouns on your resume.
Roger that.
Roger that.
That that will virtually guarantee that your resume gets thrown in the trash.
Have you guys heard of or know Steve Hicks, N5AC?
Ooh, that call sign sounds vaguely familiar. I don't know him.
Yeah, he's vice president of Flex Radio in Austin, and he's an A&M
Oh,
grad.
Oh, gig 'em.
Good
Nice.
gum.
You need to contact him and get Flex Radio support and have Steve come over and talk about SDRs.
okay. I'm making a note of
Perfect.
that right now. Give me one
Thanks.
second.
Do you by chance have his call sign again? Because I
N5AC.
think
Yeah, November
N5AC.
5, Alpha Charlie.
Perfect. Then I could try to contact, or we could try to contact him through our, was it QRZ or some other means? I mean, if you have his contact information,
Or
um,
flex.
or Flex, yeah,
Yeah, why don't
easy
you just
enough.
try calling Flex Radio first? I don't want to put his personal cell phone out here right
Oh,
now.
definitely not. I could also give y'all my email as well, and I think my members as well as James and Eric. Eric is actually helping my committee, the Interorganizational Coordination Committee, and that's kind of
Hmm.
our way or our own group to kind of branch out and get all these sponsors you see before us.
Yeah.
So I'll add my email just so if anybody has any questions. Oh, I just saw other pictures. We could go back on the
Email.
pictures.
Yeah. There's a couple fun ones in there. Roman, could you go back to the parabolic dish one?
Yes. I can actually give a little bit of backstory, a little bit of rag chewing on my end because at that time I was kind of alone. And you see right here at the top right corner, that was myself, a graduate student at A&M called Ferris Nguyen. We had James, and then Bailey Hollis, who is also a member of MTTS TAMU. But this kind of came to me in not a pipe dream, close to a pipe dream, but it was where I was starting MTTS Tamu, and I kind of needed gear as well as a learning experience for our members. And what I came up with is like, huh, we got a parabolic dish. I see parabolic dishes around. There's actually one laying on the ground where I went to school. I would see it every day, and I was like, okay, how can I possibly make this out of one of the low costing materials I could find? And my job previously was at this maker space workshop at A&M, and they were just getting so much cardboard in for these materials that they're giving the students that there's just this whole entire spare cardboard. And I was like, I could do something with that. So I kind of came up with this idea to use MATLAB, get them involved to one, supply the software in order to simulate the parabolic dish itself for geometrical kind of measurements as well as its electromagnetic properties. So this right here was about a 16-degree beam width, high power beam width, and then
Frequency.
2.4 gigahertz using a ADI Atom Pluto, also programmed using MathWorks. So yeah,
Al,
so
we
it's
need
2.
to give him the 1960s articles on stress parabolic dishes and chicken wire.
Oh, I was thinking about chicken wire. Yeah, I thought about chicken wire for instead of aluminum, but I had aluminum in my pantry, so I was like, all right, I'm either baking cookies or I'm making a parabolic dish out of this. So, uh,
If your eight radials were like aluminum tubing or something like that, if you grab the
mm,
end and pull up, it naturally forms a parabola.
Interesting.
hmm.
Okay.
Naturally. Yeah.
So just by having some guy wires coming back to the center, you form the parabola.
Oh wow,
Interesting. Yeah,
that make
because
it
the way that we
Interesting.
did this is we kind of measured the cardboard, and then I went and
hmm
kind of cut like a curved form that we could go lay the cardboard over and kind of tape it together and then put aluminum over the surface and then smooth that out. But I think that's interesting. I think we need to look into that.
Yeah, definitely. I'll make a little note of
Uh,
that.
K2,
It won't be perfect.
uh, look up K2 RIW, K2 Romeo India Whiskey. It was published in QST and several other places. K2 RIW,
Do you know what
Got
the
it.
name of the QST article might have been?
about 1970.
Okay.
It
I'm
was
gonna look into
used.
that.
It was used to listen to the Apollo astronauts while they were circling the moon.
Oh,
How?
Okay.
Since they were actually listening to the guys on S band while the dish was pointed to the moon, certainly highly suggests that they really went to the moon.
Right, living proof. That's
living
good. We'll
proof.
take a look in that. But yeah, we kind of just use MATLAB code to kind of simulate it in their program, and then we create it using not too much tape, but tape, cardboard, and aluminum. And you see on the right image, right below our image in front or behind the parabolic dish, we didn't build a mount because we were I didn't want to take everybody's afternoon. So this is about a 4-hour project. But ideally, we would have these individuals basically build their own can antennas and then mount it to the parabolic dish to then be tested. And
Now,
again,
whoa,
this is
whoa, on the cantinas, I hope you're not using
mhm.
Pringles cans.
Nope, it's not Pringles. It is good old HEB coffee cans. So
Okay, because we have proven that Pringles does not work at 2.4 gig.
yeah,
That's
definitely. I think
pretty
that's
cool.
too small for that. But yeah, that's what we're doing for this idea and this kind of project.
But the
And we're
problem is you don't listen to a lot of satellites and stuff up there with an indoor antenna.
You don't. And the reason for this project is basically getting people to kind of learn through, like, I believe, 4 workshops to, like, say, solder on their own SMA connections to the coax cable, building their own CAN antennas, getting some theory on that, getting some theory on programming an SDR, well, mainly theory about like parabolic dish, but learning how to program an SDR, such as the Adlon Pluto. And then they construct this parabolic antenna to then compete to see who has the narrowest half power beam width. So we used like a portable spectrum analyzer to kind of gauge the half power beam width by just standing in front of it and then moving across it in an arc. So that's kind of the purpose of this. We can't really listen for it just yet, but probably once we get better at this and we get more theory under our belts and more students have that theory under their belts as well, we'll start to kind of see if we can do some satellite communications or something around that agenda. But for right
For
now, it's
for
mainly for student. Oh,
for what it's worth, 30 years ago, I was teaching microwave course at the Tarrant County College, and I gave all of my students a WR90 waveguide flange and said, "Okay, this is an outdoor lab. Your grade is 30 plus dB gain of whatever antenna you build." And they all went home, built 10 gig antennas, and the winner was a 6 foot long conical horn made out of sheet selenium.
wow.
Selenium.
See,
He,
that's the kind of crazy we need.
Another guy went down to a junkyard and found the biggest parabolic hubcap he could. And the lad worked for a copier company, and the sheet selenium was used for coating the rollers.
Wow.
Interesting.
Very
Yeah,
interesting.
we don't have that much money just yet, hence the foil and cardboard, but that does sound like some project that we could get into or at least try to expand upon with this parabolic dish. That's really interesting, huh? But yeah, the whole purpose of this is to just introduce students into just building and getting familiar with the RF and microwave side of things. And then,
Another lab that worked well was I brought in a radar. We went out in the parking lot and measured the radar cross sections of the students' cars.
oh, nice.
I demonstrated taking 92% of the radar echo out of my van. Some enterprising lads took 99% out of a 68 Mustang. Ooh, extra points.
Dang. What type of radar were you using?
I was a little X-band one. Um, the 75% of the radar reflection are the headlights. They're parabolic reflectors aimed back at you.
Mm.
It's like pointing a flashlight at a cat at night. Put some window screen over it, and that knocks it down a lot. They took big sheets of foam rubber, about 3 feet by 6 feet, poured water on them, stomped on them, and tied damp foam rubber all over the front of the car, and just soaked it up.
Wow.
Interesting.
That's really smart. That's pretty cool because I'm actually researching under a professor who's very interested in radar, mainly cognitive radar, and she's doing some, I think, RCS measurements with I think drones right now. So she's really into like micro Doppler, and we might have like an MTTS TAMU led like radar competition with our aerospace department and their design team for vertical flight design for where they have a quadcopter, and we'd be building our own radar in order to see if we could either capture it, get the best SER we can, and then they'll have to design their quadcopter in order to evade us. So that's pretty cool. I'll probably ask you some more questions later in the kind of semester
Uh, well,
about
uh,
that.
we can trade phone numbers or something. I do electronic warfare professionally and have 1,040 antennas doing EW in the
Oh
Ukraine at the
wow.
moment.
Oh
Whoa.
wow.
Wow.
Professionally, so what company are you at?
My own.
Wow.
Oh, wow.
Got it. So we'll definitely be in good contacts with you then. Are you based in Texas, obviously, or
Grand Prairie near Dallas.
temporarily? Perfect. I'm actually from Plano, so I heard somebody was in from Allen. So yeah,
That would be Al.
nice. Well, glad to see another Collin County individual resident. I'm glad that they got 75 actually taken under control because I was coming there from College Station, I think maybe 6 months back, and it was just horrible, all this construction. But no, definitely. I'll definitely see. I'll send you a direct message with my phone number and
Okay.
email.
Okay. WA5VJB at
Mhm.
WA5VJB.
Got it.
You can also visit wa5vjb.com. I've done about 1,100 different PCB antennas. Got quite a
Hmm.
sampling on the website, 1,100 different ones.
1,100 different ones. That's crazy. Wow. Well, I appreciate you just coming to this meeting to let us present to you, as well as to all the other NTMS members. And I want to say, do we want to view any other photos? Let me see.
Got one other comment. Have you guys seen W1GHZ antenna handbook that's online? That
I have
talks
I
Uh,
talks
have
a lot.
seen it, I just haven't read through it.
talks a lot about how to illuminate dishes. It's got a lot of modeling results, a lot of very cool stuff, and because it's free and it's online, and that's another one of the guys that is one of the lots of built-up experiences. You can tell with Kent and Al, a lot of guys. W1 and GHZ, and go look at that handbook. I think you'll have some fun there.
Yeah,
So I
I
got a
thank you for
W1
that.
GHC. Is that correct?
Yeah, Roman, I
GHZ
got
like
in the Discord.
gigahertz.
Like gigahertz.
Perfect. Got it. All right.
Yeah, got it.
Then
Nice.
James, you already got that?
Nice.
Yeah, it's on our Discord, so our members should be able to see that.
Perfect.
Ooh, wait, nice.
Yeah.
Nice. And then,
This is
yeah, like
very
James was,
nice.
yeah, like James was saying, these are our previous pictures from the Texas A&M Core Cadet Signal Corps, and yeah, I found these from our website. I mean, these are W5AC members. So we have our other organization that deals with like RF and mainly ham. They're our hand club at the university. But with their kind of like roots way back in the day, I like to think that any RF and microwave at A&M or student at A&M has their roots with the Signal Corps as well. So I really like these pictures because they're working on like a switchboard on the bottom right. They have the transmission line where you have like the sergeant of the day who's presented out in front, and then you have bottom left, like James said, Morse code, or they're doing CW work for receiving class. And then for our right side, the top picture is actually my professor's booth, my PI's booth, where we're kind of teaching individuals about basic RF and microwave and presenting I believe, I can't remember, I think it's like an 18 gigahertz radar. It's a MIMO radar. And I'm just demonstrating like a frequency using my hands and waving it, getting them more involved. And then obviously the parabolic dish to the bottom right, and then to the left, this is actually our members. So we don't have that much money coming in, but what we do is we partner up with our department and we kind of do a little scavenge party to kind of bring to life discarded pieces of equipment from our department. So yeah, that's kind of our members right there, or that's three of our members, including Eric, just participating in this little scavenging event. Eric, do you want to describe anything from your slide?
That IEMSL cutout. There's a laser in the lab too, so that's where that comes from. And then that's just me at First Friday, which is pretty close. It's in Bryan, Texas.
Yeah, First Friday is
It's
amazing. So if y'all
yeah,
come down to College Station, they have it like every single month. First Friday of that month is this really like a flea market, farmers
yeah,
market, and
yeah,
some party. So I'm glad you went, Eric.
yeah.
And then for this, yeah, I don't want to go over too much and bore y'all, but wherever I'm in the suit, that was kind of recently in the Waco, Texas Wireless Symposium. It's where I presented a paper over the MI or how we kind of did another iteration or version of the MIT's 2.4 gigahertz radar, FMCW radar. So where we basically took their hardware components, their front end of their RF and their TX, and basically included a FPGA and a Raspberry Pi. So it could change its chirps dynamically depending on a target's range and whether it could pick up that target using peak detection. So whether I'm in suit and Baylor, Baylor backing, that was in Waco, also talking to our sponsors at Rodian Schwartz. Then the other two, or say like the middle over here. So this is actually during our Texas A&M's first ever semiconductor summit tour. I got our sponsor from Cadence, and then they had me present to, I think, about like 70 people about MTTS TAMU. And then that's also in the bottom right here. I'm also presenting to individuals from like North Texas, or yeah, UNT, and then some other folks around like Oklahoma, Texas, maybe some out of state as well. And then for this picture right here, this is where I went to IMS. So if y'all know about IMS, it's happening Monday, and I'm actually going to be presenting at IMS with the Project Connect. I was an organizing committee member, so again, I'm introducing more people into the RF and Microwave Society. And if there's any Aggies in the call or any former cadets, obviously me and Khaki, me and my ACUs, this is my time as a cadet. So I've really taken what I learned through like my Core Cadets experience, my time as a researcher, and I kind of put that all together to create an organization of MTTS Taming to help people kind of be in a better spot to get into the RF and microwave community. I think that's all the pictures I have. And I think I'll go back to kind of our any more questions for us or comments?
You had some pictures from the 1920s and then modern day. What about us guys from the late 70s at W5AC?
Ooh. Oh, we got a W5AC member?
Indeed.
Oh, perfect. Well, howdy.
Howdy.
Um,
Howdy.
Howdy.
it's kind of weird. I actually got all these like signal core pictures from the Cushing's library, and I had to email them, and I tried to squeeze out as much information I could from them, and they only had these individuals. W5AC, I'm a member of W5AC. James is also a member of W5AC, and I understand that they just don't have access to any other pictures. But I mean, if you have some pictures and we could pass it down to them, we could pass it down to W5AC as well. But it's Keith, right?
Yes.
Hey Keith,
Perfect.
by any chance would you know a Tom Talley W5XTT?
What was the name?
Tom Talley, and his call sign was Whiskey 5 X-Ray Tango Tango.
No, doesn't ring a bell.
Okay. He's another one of those W5ACers, but his class year I think is 1971. So maybe a little bit before your time.
Yeah, I was class of 80.
Okay.
Got it. Red ass. Nice. So, I mean, if you have any pictures, we'd love to kind of share it because I think the pivotal point about, MTTS TAMU and how to get members involved in microwave is obviously like the history component to say if we had students all the way back from 1920s or in the 1980s be able to do RF and learn RF and microwave, then the students in the modern era could definitely learn. So, you already have my email in the chat as well. So yeah, hopefully we could find some more pictures from W5AC or just like Signal Core, include them, kind of bring it out into the modern era. But if you have any, we would love to have it and kind of pass it on to W5AC as well. All right, but any other questions?
Um, Hello, this is David, November 5, Yankee Alpha, November. I was just wondering, I heard you guys got some radios. Do you have a shack, or are you planning on doing mobile operations? I'm just curious what the plan is for that.
So we actually got, I believe, 5 radios in total. So we got one ICOM 905, thanks to James, who connected us to DX Engineering and ICOM. And that's kind of going to be our microwave UHF, VHF Go kit. And then we got four Jesus. I forgot the actual numbers following it, but we have four Jesus handhelds.
FT60R.
James, say again?
FT60R.
There you go. So we have four Jesus, FT60R, and those are for mainly introducing people to our weekly or W5AC's weekly nets, as well as operating on repeaters and then performing fox hunts. So that's kind of like the scope of those radios right now. And the equipment that's going to be provided by y'all basically will be used to kind of either implement it into like fox hunts, learn more about RF and especially the ham application, the radio frequency or the microwave frequencies, such as like the beacons. And then I believe y'all are also donating a frequency counter, which we'll definitely find a use of teaching individuals about it. But for right now, that ICOM 905 is going to be developed into a Go kit to maybe operate in the UHF, VHF, and microwave regions. And then our Jesus is for mainly demonstrating and getting people hooked into the microwave and RF society and kind of what we do. So yeah, does that answer your question?
Yeah, it does. I'm a student at UT, so we have an
Oh,
amateur radio club. Yeah, I'm sorry. We've got an amateur radio club. It's not very active. I'd say I'm probably the only member currently who operates on a regular basis.
mhm.
But we have a VHF UHF weak signal set up, and I'd love to try and
Oh,
contact with you
nice.
guys. I'm
That'd
also
be
currently,
amazing.
I'm currently an employee at Skyworks Solutions, kind of an RFIC company, and me and
Mhm.
some coworkers are working on creating an amateur radio club. So if it
Cool.
ends up working out, I'd love to create a line of contact between you and them for career opportunities, but also possibly a sponsor or some other like way of interacting with your org. I think that'd be
That'd
good
be
for you guys.
amazing.
Yeah. All right. Thank you.
Yeah, thank you, David. It's funny enough you say about that. We are also trying to get sponsorship by Corvo. We're going to be solidifying this or their sponsorship by this summer, and I'll be seeing them in IMS. But we are going to plan on having their ham radio people come down and kind of do like either a seminar, a workshop, maybe a fox hunt with ourselves, and obviously invite W5AC. But to so if Skyworks, if you get that hosted up, we would love to talk about maybe hosting y'all's ham radio club over here, as well as just having Skyworks as a sponsor. Because as Roding Schwartz as a sponsor, they're having their own like micro exhibition that helps setting up that we're all helping setting up. So Skyworks would be kind of getting their roots inside A&M through that, through seminars, and I could just go on and on. But definitely send me an email about that. And for the next thing about the Longhorns connection with the Aggie Land, definitely I would love to set that up because what I ask for all these MTTS society members or student chapters I meet, I always ask if they have like ham radio club because I think the two are in tandem. And if you could get me that contact or just send me an email and we could start doing or start building a channel in order to discuss more about that, I would love that. So yeah, so David, just send me an email and I'll be expecting it.
All right. I put my email in the chat. I should clarify, I'm an intern and soon to be part-time employee of Skyworks as I finish up my university degree. So I don't know that I have the pool to get them as a sponsor, but the club itself, if that ever comes to fruition, would be more than willing to work with your organization.
Perfect.
The problem is most of the employees I know that are interested in this amateur radio club are in Cedar Rapids, Iowa, which is quite far away, but we have Zoom and technology now. So,
right. I think the first place to start for any type of sponsorships comes from working with their university relationships. So I could also do some digging myself. I'll see if they're at IMS. But yeah, I appreciate at least if they start up their own ham radio club. If you want to be the point of contact from there, we'd love to try to work with them on either repeaters, maybe it's open propagation, stuff like that. So, but I appreciate it, David. And you're still a student, is that right?
Yeah, I'm a student, undergrad. When and where is IMS? Is it in Texas this year?
No, unfortunately, it is in San Francisco, and it'll be in Texas in 2027, summer 2027.
All right, thanks. Have a good one. I'll stop hogging the floor now.
And no worries. Great to talk to you.
Any other comments, questions, concerns, insults, jokes, or marks about the weather? We're happy to hear it all. Well, hearing nothing. Next slide, please. Thank you all one more time for letting us present at this meeting, and thank you all for agreeing to be a sponsor. We're really excited to see what we can do, and yeah, just one last big old thank you from Roman, Eric, and I, and the rest of the MTTS TAMU team. As we say in Aggie Land, thanks and gig 'em.
Thanks and gig 'em.
Thanks and gig 'em.
Waiting for Keith. All right, guys. I just wanted to mention that I'll send some pictures to James, but the noise figure meter is a Hewlett Packard 8971B, very common noise figure meter, and the noise source is good to 1600 megahertz. It's just kind of a lower frequency, but definitely usable for observing your noise figure measurements on anything at VHF. and then up to and through 1296, which is one of the ham frequencies. And I was thinking maybe we'd check into the availability of some kits for 1296. There was a gentleman that I know Hint knows very well, Sam, Golf 4 Delta Delta Kilo, I think was his call. And he had a really high performing 1296 LNA that you could buy as a kit. And I think Kent actually was the distributor in the United States for that LNA. So anyway, that ties all together kind of.
Hey, Jim.
And the fellow that's donating the noise figure meter is November 5 Sierra Kilo Echo. And his name is Greg. And he says his name is Gregory Boren, Boren. And when I told him about the organization that you guys have, he said, that sounds like a worthy cause. I'll donate. I'm an IEEE senior member.
Good
so
goal.
that's where
Very
that's
good
coming
goal.
from.
Wow.
Matt's KD5 Fox Zulu X-ray. Matt's actually holds a lifetime Swedish call as well, is where the 18 gigahertz frequency counter is coming from. And I've got that here now. So we'll need to make a trip with some of this stuff. We're still, going to be a few weeks before we get the RF zeros from Bo, is his name, B-O, where those are manufactured and shipped from. He's agreed to send us two at a greatly reduced price. I mean, it's almost nothing.
Wow.
And I know that is really, to me, really applicable to a proper syllabus that would go around it. Because first of all, it's a very much a cost versus benefit kind of design. It's not, cutting edge or next generation. It's basic. It's got a very basic GPS receiver. It's got corrective things that they built in to try to reduce the jitter. It's got Arduino Zero. So other than the, I guess you'd say, more complicated code to address the RF module that's on board, the rest is pretty much stuff that RF engineers are one way or another. It's going to be software guys or hardware guys, but exposure to both sides of that would probably prepare a graduating student. And one thing you didn't mention, Roman, is that the participants in your program don't get college credit.
They do not. So mainly what they get is kind of experience and networking with these companies and their sponsors. But yeah, they don't get recognitions through like the ESEN department, which is electrical and computer engineering department, to where they could be a part of MTTS TAMU and they could say, hey, this is a credited organization that will help me graduate, and that credit goes to like I think it's a high impact they call it. So as of right now, they aren't giving us that kind of recognition. So hopefully by the end of the summer or hopefully by the end of fall, we finally get that recognition and get that credit. So we have people graduating because of their MTTS TAMU membership.
Yeah. Well,
But
I
that's
can think
great.
of nothing probably more rewarding than to give to you guys impart something that will help the future generations to be better off than they would be without that. So looking forward to more and more collaboration.
Definitely. And we definitely appreciate your contribution and all the NTMS's contribution to MTTS TAMU because, again, like you just said, helping the next generation kind of be better off than what we were. So we just really appreciate y'all's participation, y'all's comments, questions, and just helping us be the best organization we can be.
All right.
Jim,
Anything more for?
This is Al, Jim.
Yes, go ahead, Al.
Yeah, the noise figure meter, and you think you may have the number wrong. It's unless it's a noise figure test set, the 8971 is just a down converter. The 8970B or A is the noise figure meter. I assume it's probably an 8970B.
There's 8971B.
Well, then that's not the noise figure meter itself. That's the down converter.
Okay, so it really needs a meter behind that.
I mean, it may be the 8971 test set, but then you'd also need a sweeper to go with it.
Okay.
Which would be three pieces, 8971 and 8970, and then a sweeper to go with it. But if it goes up to only 1600, it must just be the 8970B, like the units you have now. I think that was a B, and it goes to 1600 out of the box.
Okay. Thank you for that.
Okay.
All right. Anything else before we move on to the exciting Tropo opening? Then I'm going to pull this up. There we go. Okay, when you're ready, Al, it's all yours.
All right. Well, I'm going to talk about the nice trope opening that we had across the Gulf. That was the middle of May, and I'm going to include some information from some of our Floridian hams that I worked on 2 and 5 gig, and they provided some input, and I will turn it over to them at the appropriate time if they have some additional comments over what's in the presentation itself. But I wanted to include them. So if you go on to the next slide, this is something that we look at, I'd say daily, and you look at it early in the morning and generally late at night. And this is what the APRS map looks like when there's great tropo going on. APRS is a bunch of 2-meter radios that, digital radios that are communicating amongst themselves, and the paths are documented here. And if you actually click on one, you can see the stations that are making contact, if you will. And this big old blob here happens when we have weather conditions or fronts moving down from the northwest and also from the north. And that's one advantage of living down here in the warm, muggy south is you get a lot of this going on. And usually if you get on 2 meters, you can hear quite a bit of activity. And we do watch a lot of 144, 174. I mean, I watch that daily because it's a real good band for seeing who's working who. And a lot of times we have conditions like this that really don't extend much above 2 meters or 432. But on this particular morning, it was a lot different. And we actually worked through 5760, and I'll show some of the information on that. But this doesn't, the actual red blob that you see here happens pretty often this time of year. But whether or not it supports the higher frequencies is the big question. So you just have to get on and operate. You do like what Buddy down there in Florida does. If I get on 432, he'll ask me if I have 1296. Then he'll say, "Well, do you have 2304?" And he actually walks me up the band. So he's guilty of that. So I try to make sure I have everything ready to work Buddy going up and up the bands. But the only other, the other times that we've had great conditions, I took some notes here. I mean, back in May 2nd of '06, we did some 3.4 gig into Florida. And let's see, on June 4th of 2012, on 5 and 10 gigahertz, I worked K0VXM. So I would say since 12, let's see, what is this year? It's 25, 13. I think I've worked a little bit of 2304, but never anything higher than that. I don't believe in between those time periods. So it doesn't happen that often. But I'll show you the fun that we had. Let's go on to the next slide, Jen. Oh, back up one. Yeah. Oops. There you go. Hands off. All right. This is one of the problems we have on 5760. We're not alone anymore. And I turned my antenna down to 107 degrees towards Buddy's house. And this is what I saw on 5760. And I'm thinking, well, how the hell am I going to work anything through that? But I thought, well, we got to give it a shot. Buddy had a 100-watt amplifier on 5760, a dish that he'll talk about. I had a 150-watt SSPA in the shack, and I don't have a picture of this per se here, but I'm using some WR137 waveguide to go feed a dish going to a fly swatter, and I have some pictures of that. So I asked Buddy, I said, "Buddy, can you go to Q6530A? Because I want to fit his signal in between the spurs on 5760." So you can see down there in the waterfall, that's Buddy's signal out of Florida. And on peaks, it actually was moving the estimator pretty good. We could have made a contact on CW, but when you're set up and ready to go, I don't care what mode it is. I'm going to work the guy. I guess we could come back, later and work, but when it's sometimes it's such a struggle to work through all this QRM, the commercial ISM type stuff. But this is a 936-mile contact. And if you go on to the next slide, it'll show, we use WSJT X, and probably a favorite weak signal software, if you will. And you can see where you can see Buddy's signal on the waterfall. Those spurs actually didn't show up very well in the waterfall, which is good. And basically, I see a signal. You can see the sync tone around 900 hertz. And then you can see the anticipated width of the signal by the red line. And you can see what I decoded out of Buddy. And well, actually, this is down at Buddy's place. That's right. Yeah, I forgot. This was down at Buddy's place. So he's not going to have all the QRM that I had. But yeah, we swapped some pretty good reports, basically close to 0 dBm or a little bit higher. And, those are really some audible signals. It's not like they're buried in the noise. I'll show you some later that are actually a lot weaker than that. Let's go on to the next one there. And I'm going to show two slides here of Buddy's antennas. And then I'll open it up to Buddy if he's got any further comments, and we can back it up. But you can see the dish that Buddy was using. It's I call them barbecue dishes, but they're really Wi-Fi antennas. And this one for a 5760, and this is the manufacturer. It's Laird, and it's a fairly small dish, but managed to work pretty well. And you can see Buddy's VHF Yagis. So when I went to, if you go on to the next slide, and I'll show you, this is the kind of the technical data on that Laird Technologies dish. This is the one that Buddy's got. It's a small dish. It's only about 11.8 by 15.7 inches, so it's not very big. and it doesn't have a lot of wind load because it does use ribs. Buddy, did you want to say any more comments about the dish you're using, or the prior slide, or the contact?
Not a whole lot. That's an antenna that I could fit where on my tower, which I am kind of out of wind loading. I had a near miss with Hurricane Milton, so I really couldn't put anything very much more up there than what I've got. Really, the only comments I've got on this is that this was a long time coming. I think you and I worked for this contact about 2 years, and I believe this was the second cross Gulf contact on 5760. And little did you or I either one realize that the third contact would be coming up in less than 12 hours.
Yeah. All right. Well, let's move on here, and we can talk about that other contact. I use a fly swatter type of antenna on 5760 and also 47 and 76 gig. You don't see these much anymore. I think Jim spotted one on an AT&T tower out in West Texas, but basically we're reflecting a signal off of a reflector up my tower, and the reflector is at a 45-degree angle with respect to the Earth. So basically, angle of incidence equals angle of reflection, and you get a signal that's been sent out to the horizon. And this is the dish that I use. It's kind of mangled up a little bit. It's not a very pretty dish anymore, but I use a 5 and 10 gig feed, one of the first ones I came up with years ago. I was thinking about putting a 10 gig transverter out there as well, just to see how it compares with my other antenna. But I'm using some WR137 flexible waveguide, and this is on a rotating tower. So the beauty of this is when the dish rotates, so does the reflector. And if you go on to the next, well, before you, yeah, why don't you go back? Sorry. I just wanted to show kind of Buddy the other antennas that are side mounted on the tower with the tri-bander. That represents 24 gig on the bottom, 2 and 3 gig, and then 10 gig up at the top. And they're up, I don't know, about 70 feet or so. And the wind has gotten a hold of my 6-meter antenna, or no, 220 antenna over here. So the wind is even, wreaks havoc with us here in Texas as well. And we don't get your hurricanes up here. All right, if you go on to the next slide, it'll show a close-up of the fly swatter. This is one that K5BOU originally built, and it's got an actuator on it for tweaking the elevation. And Craig actually rotated this one in azimuth for his installation because it was on a fixed tower. So since mine is on a rotating tower, I don't have to rotate. I keep it fixed. And I could vary the elevation at one time, but I lost the elevation indicator. So I wasn't about to try changing anything without knowing where I was and where I was going. But this is below the second rotor loop, if you will, or second guy point. So it's up about, I don't know, 55 feet or so, I think. And that's what I use to work Buddy. But I've also used this on 47 gigahertz to work Jim at 99 kilometers and on 76 gigahertz. But we only worked, I don't know, what was it, 20 some odd kilometers, I guess. I was kind of local. So if you go on to the next slide, Jim, I've got a couple of slides here on Eloy's contact. And this was, we went to work on 13 centimeters. Eloy's down near Miami, which is about, I don't think he can work too far south of that. But Eloy, would you like to comment on your setup here?
Well, not really. What can I say? It's just an apartment, so I'm very limited in what I can do. So everything's basically portable. It's like a rover operation in place. Also, there's no cables coming inside the apartment. Everything is done through Wi-Fi. There's in the on the right picture, there's a 905 control unit, flex radio with a transverter for VHF, which to be honest, I rarely use because there's so much noise in VHF over here that just with 10 watts I'm okay because I'm able to be heard and to hear whatever is hearing me. So more than 10 watts usually doesn't make any sense for me. I stay with the 905 and well, the only inconvenience is I have to change the antenna every time I want to change the band. So if you want me to go to a different band, you will have to wait for me to go out and change whatever I have to change. But besides that, the height helps a lot. The only inconvenience is the real one is the noise of the city, everything around, all the wireless connections. It's impossible for me to work 2304 without a bandpass filter, a good one. Have to connect the filter also. The picture with the dish, I see the connection is for 2760 because there's no filter installed at that moment. And that antenna, since we made the contact, has changed a little bit. I've put some copper tape on it to try to improve the performance in six or close to 6 GHz. The separation is too much for the frequency, so I guess there's a lot of leaking on the back of the antenna, of the reflector. Let me see if I can. Let me change something here on my settings. Background and effect. I'm trying to go with that one now. So I'm changing the antenna. Changing also the reflector.
How many feet in diameter is that?
3 feet.
Okay, good.
And I'm ready to take everything outside.
Well, 1,105 miles is a new 2304 record in the U.S. So
Congratulations, guys.
Yeah, congrats. Wow. And is that only for 10 watt?
2 watts, right? On
Only
Eloy?
2 watts. 2 watts.
Only 2 watts. Wow. Interesting.
I was only running about 300.
Well, I don't know about you, Roman, but I'm certainly taking notes on this.
Most definitely. Maybe we should try to contact y'all. Um, so where were y'all set up? I'm trying to gauge the distance on if we could even compete with your record because we're going to be operating College Station. If you're saying out in Florida,
I'm in North Miami.
North Miami, okay. So we might try to do something.
You can look at the locator in the picture,
Mhm.
EL95. You can use that to locate me.
Perfect.
Why don't you go on to the next slide there, and you can see a close up of Eloy's antenna, at least the dish. And this is it uses something very strange. It looks like it's a log periodic feed. Kent, did you have anything to do with that?
If that's the character in Florida making them for South America, yes.
I guess the only concern is I did some looking at to spacing for 5760, and a wavelength is 2 inches, and a tenth of a wavelength is 0.2 inch. So it seems like 1/4 inch mesh might be something good to put on that dish. But what's the spacing right now, Eloy, on that antenna?
Um, 1.5 centimeters, I think. 1.8 centimeters. That's what I
Okay.
measured. I put in some tape. I put some copper tape after we made the contact, and I tested again in 5760. The front to back improved. I stopped receiving my own Wi-Fi at that point.
And you
I
stop
noticed the diff.
illuminating yourself.
Yeah, I noticed the difference. But the rest I haven't really tested with someone else. Well, I tested with Body 2 weeks ago. We have every Monday we have activity night, and I was able to make the contact with body, which before putting the tape was very hard, even would say impossible. I was able to receive him, but with only 2 watts on my side, he never hurt me before putting the tape. By the way, the manufacturer of the antennas, of technical antennas, it's right now he's logged into the Zoom meeting. It's Raul Pla, but I think he has issues with the microphone and the camera. I was texting with him a while ago.
Hi, real Kent.
Is this the same as Antenna World?
Yes, he is the same.
Oh, okay.
Yes,
I
that
wouldn't.
is my feed.
Okay, I wasn't aware of that. Well, anyway, it's proof it does work. You just got to have to get Ned to change the standings. All right, let's see. Let's move on to the next slide, Jim. This is one that really surprised me, and I see that Mike is here. Mike is running. Let me see. Let me just show our contact here first, and then I'll go on to the next slide, and then see if Mike wants to make any comments about it. This one really surprised me. But let's see, this is on 5760, and Mike wanted to run on Q6515A, and before I could get him to change over, I was decoding them, which really surprised me. I mean, this is interesting in that WSJTX is smart enough to not try to decode anything out of these spurs from the local, Wi-Fi. And it actually decoded his signal right through all that. So I was quite impressed. And I was able to decode Mike at minus 23. And we actually went on to make a contact. And that was 931 miles. So if we go on to the next slide, this is a screenshot down at K4DJ. And would you like to make some comments, Mike, on that?
Well, yeah, I was kind of surprised as well, Al, that we made it, given the amount of power I had arriving at the antenna here. Everything's still a work in progress. And as you'll see on the one slide, my feed line loss is rather extraordinary. So to be able to have you hear me, I mean, you were quite loud here, as you can see there. I was seeing you at let's see, on 6 centimeter. Yeah, I mean, above 0, plus 4. But for you to be able to hear my milliwatts was, I was pretty astounded. As a matter of fact, I think I texted you on the chat forum that I was about ready to give up. And then all of a sudden I got a reply.
Don't ever give up, right?
Yeah, it's a good thing you can hear well.
Let's go on to the next one there, and you can see what Mike was fighting.
So everything's a work in progress. Matter of fact, if you look at the picture, you can still see the pulley and rope hanging there where I'm still working on it, but that's exactly how it was when I worked out. And the list there is the kludge of feed line going out to the antenna. The antennas originally were up close to the shack with a short piece of LMR 600. But everything to the north was blocked by a very large oak tree, and I had to get them out away from that. So I was in the process of moving everything out to the tower, but the radio has not been moved. The radio is still up here in the shack, and I'm using that kludge of feed line. If you read through, that's all the pieces involved in getting the signal out to the antenna. And That loss is measured loss. That I've actually put a signal in one end of 0 dB, and I measured the loss out the other end with the spectrum analyzer. So there was 40 milliwatts at the antenna, and Al was able to hear that at 5760 over 900 and something miles. That's eventually the radio is going to go at the base of the tower and eliminate a lot of that feed line loss. And still working on trying to improve the power a bit.
So go on to the next slide, and you can see his ground setup.
So you can see the big oak tree there up by the shack that was killing me on trying to work everything to the north. But I had a crank up mast about 28 feet right there. And I thought the advantage of having short feed line would overcome the disadvantage of having the oak tree, but that turned out not to be the case. That having a clear path is apparently more important.
And your little shack down at the bottom of the tower?
Yeah, there's a cabinet that's been there. I've got a dummy load for HF, a switch for HF, and all my feed line junctions, everything are in that cabinet. So I'm working on getting an air conditioner for that. I've put the 905 down in there already, but it just gets boiling hot in there, and I don't think it's going to survive in that heat. So I've got to come up with some way to keep it cool before I can put it back down there.
If you do that, what's the loss going to be on 5760 going up the tower?
It will be, I believe, 2.3 dB.
Yeah, good.
There's 7/8 going up from the box to the top. So I can live with that, especially after seeing that it works as well as it does with the kludges there. Buddy is 35 miles from me, and we work frequently on 5760 with just tremendous signals, as you can imagine, even with all that loss.
Well, you can certainly see that it was quite an impressive opening.
Yeah, it makes me kind of sad that I haven't moved faster and got that done and was ready to try 10 gig. I'm very curious. Did you try any 10 gig during that opening, Al?
No, I did not. I'm not sure why I didn't ask, but we'll have to do that next time. Let's go on to the next. Actually, there's 3 more slides before we move on. But I just put these antennas up there when Mike told me what he was running. I thought, well, I'll just put them up there because I think the price was pretty reasonable on these. And they came from Antenna World, and Raul W4AWI is the president of Antenna World, and he's on the frequency here with us today. But I don't know if there's anything you wanted to say about this or not. It's going to be in the presentation. It'll be up on the website. People can take a look at it. They can see the eBay number. And if you go on to the one on 5760, the next slide. And this one's out of stock. Hopefully Raul will have them back in stock. What's a nice size antenna? I'm not sure the spacing on it. And I guess it may be similar to what Eloy's antenna was. And you go to the next slide.
I believe it's probably the same reflector, although it's a single band feed.
Okay, not the long periodic. Which you can see even a 30 dBi antenna, it's got a 4-degree beam width. You might need something better than a ham-am rotor. In fact, what do you use to turn it on your tower, Mike?
The Yaesu 2800.
Okay.
And I may try Eloy's trick with a copper tape, maybe see how it works out for him.
Yeah, if it can withstand the weather, right?
Yeah, wind loading is a problem. I guess Eloy doesn't have that problem where he's at, but I'd have to look at that.
Or maybe some sort of like a chicken wire would be 1/2 inch or 1 inch, but 1/4 inch mesh. I don't know if that's too much wind loading for you or not, but that would be optimum probably for 5760. Any
Well,
other comments, Mike, on your setup?
no, just hope to get everything wrapped up in the next couple of months and get everything finished and ready to move up to 10.
Well, nice to meet you guys down there. All right, let's go on to the next one there, Jim. I just included a copy of my log here because I sent this into QST. But you can see I had two 6 centimeter contacts. They were in brown, and I had numerous 2304 contacts in yellow, and a couple of contacts on 2 meter and 70 centimeter. I didn't do too much work down there, but I know some of the other guys did. And let me finish up the slides here, and then we can open it up the comments and other reports on the tropo. This is a meeting of the minds down at Antenna World, and it was sent up by I think Eloy sent this one up. But you can see some guys that are down there in Florida that I wasn't even aware that they were down there, like K1DS. That's Rick, and K9AJE. I don't think I know, but that's Armando. NN3Y is Nick. I've worked him on 10 gig EME. And KP4EOR, a legend out of the past. He's Dave from Puerto Rico, but he lives in the Florida area now. He holds a transequatorial record on 2 meters that he set back in 1978, and you can see that on the ARRL DX records. And then there's Buddy, who was the first one that I really was recognized. Well, besides Rick, because I see Buddy down at Orlando at the Hamfest. And before AWI, he's the owner of Antenna World. And then N4IS is Jose. And then Eloy, lower left, W4ERP. And then Fabio. And I think that's Fabio that's on the Zoom call here, AC2AC. So let's go to the last slide there, which is probably one of the most important things: where to coordinate. And of course, NTMS Slack is a good place. NTMS Slack, we have a bunch of operators from here north because we do a lot of coordination with Kansas and Nebraska, and then we venture northeast a little bit, but it's somewhat geographically located. But we opened it up to anybody. I mean, we had Eloy. He's been on there pretty often recently since the band opening. So if you're interested in that, we can certainly send you an invite, and you can try that out. The other thing is there's a VHF chat Slack. I think that one's by W5TM, and there's a Fourlanders group on that, and a lot of folks hang out there. And that's probably more encompassing larger area than the NTMS Slack is. And then, of course, ON4KST, Region 2, which we're part of. A lot of guys use that, and that's kind of nationally. And you see a lot of people from Midwest to Northeast, and they have other subsections in there as well. And K4JMX is the one that I was introduced to here recently, and that's where I did all my coordination with the Floridians, and that's K4JMX. And there's been a W4DEX chat that's been around for years, and it's still very active, but I guess it's more of the Carolinas, and of course that's where Dex is from. So those are all good places to coordinate. And I guess the last two things, if anybody else has any other places to hang out, that we need to be aware of, please feel free to let us know. And are there any other tropo reports? I know AA5AM was making a lot of noise in the contest, and maybe he's got a report. So I'll just kind of open it up right now, and then you can turn it back to Jim, let him coordinate closing things up. But any other questions for me? All right. How about other places to coordinate? Are there any missing here that need to be added?
Have you all ever considered trying to start up like a Discord server or something for coordinating?
What was the word you used?
Discord, Delta India, Sierra Charlie, Oscar Romeo Delta.
I'm not familiar with that.
Okay. Well, it's one of those online messaging um websites, platforms, you name it, that are pretty popular today. I know I'm on more than a few. I'm on the Texas A&M Amateur Radio Club Discord, the MTTS TAMU Discord, the ARRL Collegiate Amateur Radio Program Discord, and a couple of other ham radio Discords. So maybe you'll want to look into getting a Discord server, up and running to try to, cram a whole bunch of people in there to try to, organize, microwave contacts and whatnot.
Okay, duly noted. Thank you.
Yeah.
How about other tropo reports locally and from afar? Anybody else want to add anything there?
I have a question.
Yes, sir.
To Mike and Eloy and the four landers. Did you guys work anyone along the edge of the coast, or from Houston, say, to Pensacola or farther north?
Not that day.
What about beacons?
I've been trying to listen to the 1296 beacon you have, but so far I'm not sure. Yesterday there was something, and there was a red blob in the PRS map, but I'm not sure that was it. I wanted to check with Al to see if was something going on between two places, but we weren't able to test yet.
See, during that opening, I made numerous contacts on 2 meters, 432, and 1296. Al was the only contact I made on 2304, but I did make numerous contacts out that direction.
How far north did it extend, buddy?
I believe, let's see, I believe I worked W5LDA in Oklahoma. I don't have my log in front of me, and quite frankly, it just got to where these were like these are becoming ordinary contacts. I may not have even logged all of them, but I believe I worked W5LDA in Oklahoma.
Interesting.
So
the propagation mode was tropoducting, right?
There were points in between. So is tropo scatter?
See, I did work. I worked WA3GWK in Pensacola. I don't think I worked anybody any closer than that. So, it could have been ducting. It could have been just enhanced scatter, but it was a very good opening. The unique thing about it was not unique, but the outstanding thing about the opening is how high it went in frequency. I mean, as I told Al, I think I can work Al on 2304 just about any time, but 5760 proved to be the more difficult one.
See now that we're talking about the difference of 1,000 megahertz. And when we're up at 10 and 24 and 47, we're talking about so much farther apart in frequency.
Yeah, this is Scott. Can y'all hear me okay?
Yep.
Ah, good. I've been fighting with the headset. Yeah, I just wanted to throw my bits and pieces in there from that opening. Pretty much worked stuff 2 meters up through 1296. Florida being the furthest, I guess. And as far north, I think, is the Huntsville, Tennessee area on like 2 meters. And um, let's see what else. Yeah, I did work 1296. So I worked Steven, KY4G, and EM64 during that opening as well. And worked Buddy a couple, 3 times, I guess. And that was a new personal distance record for me. And first time I've actually caught in a good Gulf tropo opening on the higher bands. So it was fun. And let's see what else. Worked Vic WB4SLM in EM83 on sideband, 5.9 plus. Just a pure random contact there, and just really surprised the heck out of me. The conditions were that good. Let's see, who else I working with that opening 1296? W0PN up in Echo Mach 39, but that was extremely marginal contact. A lot of QSD on the signal. So I guess everything from about Missouri down to Florida seemed to be in that morning.
Well, that's all I've got, Jim.
Okay, great. Sorry, the cat walked across the keyboard again. Congratulations, Scott, on the personal best. That's great to get one of those in the log.
Yeah,
I just think it's so interesting how the layers, it's not really layers, but the fact that I guess we could call it the maximum usable frequency, can be limited down to just 1,000 megahertz. It works here but doesn't work there. When contrasted to what we're trying to understand, that's 14 or 20 gigahertz apart. It's no wonder we're having some challenges to understand the differences. Because I don't think we're ever going to get tropo ducting or very, very efficient tropo scatter at 24 gigahertz, but who knows?
Based on radar work, the band opens at the high end first and works its way down in frequency. The higher frequencies bend first.
For sure, for tropo ducting, yes.
And this is based on multi radars seeing the really long ground returns.
Interesting. Counterintuitive.
I think back in the old days, we used to see that when we compare 432 and 2 meters, because generally speaking, we had comparable equipment. At least on those two bands, or even 220. But as you go up to frequency, we have so many other limiting factors. We don't have the power that we had on the band below, and we don't have the noise figure, and we got lossier coax. So even though that should be true and probably is, it's just sometimes hard to see in reality just because of equipment.
Yeah, good conversation there. All right, let's see. I think that about get us to a wrapping point. I'm going to go back to the agenda. Thank you very much for that presentation, Al and the Forelanders. And our TAMU folks, hope you took note of that fact that that 905 with 2 watts was setting a new United States record.
I was taking notes. I'm excited to put the 905, through its paces next semester, and I'm also, hoping to get on some sort of microwave band here at my QTH. So I might pick y'all's brains sometime soon on, trying to set up something here at my house.
Where do you live, James?
I live in South Austin, so suburban South Austin.
Okay. Because there's, K5TRs on down there.
Oh, yep. Yeah, K5TR and K5 TRA.
Right.
I need to go pester those two again.
Yeah, they're probably the most active down there. I've worked K5TRA on 10 gigahertz, and his antenna was up in the attic.
Interesting. Okay. I worked him as my first 6 meter contact. I was doing school club roundup with the Lhasa High School Amateur Radio Club, K5 LBJ. And I said, you know what, I'll try calling CQ on 6 meters, and I called for a while. And the only guy who ever got back to me was a K5 TRA, so that's I I would like to make more contacts with him on bands I've yet to.
Well, they do have their own microwave group down there, K5T, yeah, excuse me, RMG,
Mhm.
Roadrunner Microwave Group.
Yeah, so we reached out to them too. We just haven't heard like got a proper meeting planned with them. We reached out to both you and or I guess y'all and K5 RMG because my mentor K5 EJL pointed me in both of y'all's directions. So hopefully we'll be able to work with them too.
All right, well, be sure to give Steve Hicks a call at Flex Radio.
Okay.
Uh,
We
and
actually already have the email drafted and ready to go. We're just gonna sleep on the email before it gets sent.
okay, he used to live up here and was quite active with our group, and then he went down to Flex Radio, and of course he's a vice president down there in charge of engineering. The last I knew, so. But
Well, here's hoping we can work with them to, maybe get at least, him and Flex to do some sort of presentation for our organization and maybe even a sponsorship.
sounds like a plan.
Also a
Good luck.
W5AC movement.
Say again?
Steve Hicks, also an Aggie, W5AC.
Yep. Yes. I read on his QRZ page, former president. So yeah, pretty cool.
Kind of small world, isn't it, James?
Yeah, no kidding. It's funny once you get up into the microwave ham world, how much smaller it gets, where everyone kind of knows everyone, which is pretty funny. And the fact that I just keep running into Aggies left, right, and sideways, it's good fun.
Great. Okay, so we'll go ahead and step through the rest of this, and I do have a slide here that I think the next one is, yeah. So this is the donated Systron Donner 18 gigahertz frequency counter. I didn't mean to cut this picture off so much this morning. I was in a rush, but I carried this back from Matt's place yesterday. So I've just got a little cheap frequency generator here set at 6 gigahertz and powered by that battery. And you can see we're good out to about 4 decimal places. It's using the internal reference, but it does take an external 10 megahertz ref. And I'm sure it will be very, very much more zeros there once you have a proper 10 megahertz reference plugged into the back. But the unit's real clean. It's kind of small. And I know it will go to good use This comes from Matt Kilo Delta 5 Fox Zulu X-ray. Does some amazing work, still after 20 or 30 years of building. I looked at his transverters and they're all handmade.
I've got
Every one of them.
I've got that same model for over 20 years. Works quite fine. Just be very careful not to put too much signal down its throat.
I noticed it was rated at 30 dBm, so that should help with any oopsies. But yeah.
Just have a quick question.
Thank you.
Good.
Is that synthesizer board based on the Max 2870? It looks familiar,
Yes.
and I had some questions. Okay, how do you like the performance of that chip? I'm looking to use it in one of my projects.
Well, there's people here a lot smarter than me that know a great deal more, but that is the same chip that's in the Down East Microwave Digi-LO. And this little inexpensive SIGGEN has harmonics that I can hear or I can detect above 47 gigahertz.
Okay, wow, that's good and bad depending on how you look at it. I'll do more research on it, and I appreciate your help.
It all depends on how clean and how stable you need the source to be.
Yeah, so this one doesn't take any kind of an external reference. The Digi-LO does, which will go a long ways towards getting you spot on as far as frequency goes. But this one uses a crystal on the board and it drifts. But for all intents and purposes, once you calibrate how much the power output really is, then it becomes useful for some applications. I've got several, and they were used in setting up two different LO frequencies to drive in an application. But I had to figure out what they were really putting out and then use attenuators to get the levels set just like I wanted them to be.
Oh, okay. Thank you. I guess for reference, planning on using this chip as a LO and IF generator for a homemade transceiver. So we'll see how it goes.
All right. I want to talk about phishing and scam emails because we've got a few of these floating around. Anybody that's very active on your email is going to already know that this stuff happens. And at my company, I work full time and we get regular education on these problems because it only is going to take one click on a certain type of hacking email to bring our company down. So we take it very seriously at work. Basically, watch for anything when it comes on the way of emails or texting, any out of character requests. What we're seeing is emails and, well, so far just emails being sent out that look like they are from officers of the North Texas Microwave Society. I can tell you that none of us are going to solicit through text or email. Now, you'll hear me talk about dues and how we need to support the club, but it'll usually be here in these meetings. We're not going to send you an email and ask you to do something in terms of basically compromising your bank account. So look at the return email address. I'm going to show you an example of one that went out yesterday. Look at the URL that they may be asking you to click. Look for it to be a suspicious URL. Watch for, I don't have a bullet point for this, but watch for misspelled words or improper sentence structure. And always look out for a sense of urgency being expressed. Some actions you can take is contact a person directly and or report the email as spam. So here's one that got sent to our treasurer, who is Wes Atchison. And you can see it's from Jim McMasters, but look at the return address, QWERTY3321 at virginmedia.com. And then you can read the content here. Could you please send over the balance sheet? Well, we got no balance sheet. And confirm if we have ACH or Zelle payment capabilities set up with our account. So this is the tip of a phishing email, because if we were to answer this, and provide any more detail about, well, we can take PayPal, or we don't do Zelle. Sometimes these emails can be close to convincing. I had an email from a W-2 ham operator that basically went like, my daughter is sick, and I'm just wondering if you have the ability to use Zelle as a payment instrument. I was almost convinced that was real, because it started off with "Hi, Jim," but it didn't take much, thinking on it to realize I won't answer this, and if it's any more real than I think it is, they'll ask again. Okay, let's just cover a few of the calendar items. We had our microwave activity day last week, a week ago. Today is our meeting, and the 14th, the 16th, also overlapping with the meeting, is our June VHF contest. I know that some folks are probably splitting, time between this meeting and contest. Can't blame you there. I wanted to go ahead and keep the meeting date, so I'm glad we did. Um, if you're looking for some contacts tomorrow on microwave, join in on Slack, and we'll see what we can do about getting active for you. The 28th and 29th, field day. In July, we'll have our microwave activity day on the 5th. That might be a day where folks are out still on the weekend for the holiday. Just take note that July and August are the last two testing days before the 10 gig and up contest. Then on the 12th, we'll have another Zoom meeting. I want to take note, I did see Doug Knobby here earlier. We're going to give him top billing and let him take all the time he wants, because we shortchanged him last time. And I know there was a great deal of interest in his whole house UPS system. And now he has homebrewed a 15 kilowatt hour LFP battery. Anything you want to add there, Doug?
Well, not really, but thanks for asking me. I guess my real question is, this is 10 to the ninth lower frequency than you guys are used to talking about. Are there any specific topics that anybody wants to hear about?
I think you should just start from the top, as you did in the in-person meeting, and cover every bit of it in detail. And of course, then add your homebrew battery build. And
Sure.
I mean, there's been several people express interest with me and others. So we're looking forward to seeing what you have to present again, and also on the homebrew battery.
Yeah, sure. Yeah, I can do that. I'll have pictures of my battery build, and I'm going to make a little deeper dive into what or how LFP cells work and how they're connected in series and how the battery management system actually manages the charge in all of those series connected cells. So I'll probably do that first, and then we can go through the rest of the pitch that I did in December and with some updates.
Great. Looking forward to that. I know others are too.
Good.
Thank you. And 24th to the 27th is the 57th annual meeting of Central States VHF Society in Lincoln. I know there's several folks going. August the 2nd will be our microwave activity day. That'll be our last testing day before the contest. The 9th will be the Zoom meeting. We would love to have your presentation. The 12th is the Perseids Meteor Shower Peak. And then 16th to 18th is our first leg of the ARRL 10 gig and up contest. Here's some regular occurring. Don't forget the NTMS 2-meter net every Sunday, 8 p.m., 144.260, called by Ross. The 6-meter Hoot Owl net, that will be tonight and every Saturday at midnight, 50.125, called by Al, Whiskey 5 Romeo Lima Golf. The NTMS lunch every Tuesday at 11:30 a.m. Texas Smokehouse Barbecue Richardson, 144 megahertz activity night, Monday, 7 to 11 p.m. local. T22 megahertz activity night every Tuesday, 7 to 11 p.m. local. 432 megahertz activity night every Wednesday, 7 to 11 p.m. local. And the Midwest MAD and NTMS MAD, we've noted those dates. Those are the first Saturday of every month. Do we have any old business to discuss? Any new business? I want to remind you about our need for dues. The Zoom meeting running us, well, the Zoom's subscription, I guess you'd say. Our meetings run $160 a year. Bluehost website hosting for ntms.org is 86. ARRL liability insurance is 200. PO Box is 146. 501c3 nonprofit filing with Texas is 25 a year. Total is 617. Divided by $20 in dues per person means we need 31 members to pay. Does not include the meeting room space. And well, we don't have that recently. And ARRL Spectrum Defunct Fund donations, which we regularly give several $100s. So please support your NTMS with your $20 annual dues. You can find information on paying dues at ntms.org. See the membership link on the left side of the homepage. Do I have a meeting to adjourn?
One quick comment. If you have any issues regarding FM systems or FM activity, I am again on the board of directors of the Texas VHF FM Society.
Move we adjourn.
Do I have a second?
I second it.
Thank you, Jim. Thank you, Doug. So moved. Guys, thank you very much for coming in today. Really enjoyed the presentations. Got excited again about Tropo and so many other things. They're also very excited with the association we now have with TAMU on sponsoring their efforts there.
Enjoyed
Hope
it.
to see you all on the bands.
7-3.
7-3, Jim. Bye-bye, everyone.
73.
73's off.
Bye bye. Thanks, Trace.